My name is Mark Biasotti. I'm a product manager for definition for SolidWorks, and I've been working with the company since about 2004. My background is industrial. I have a degree in industrial design, and before joining SolidWorks back then, I worked as a product designer, an industrial designer, product designer for a number of companies, including IDEO, Hewlett-Packard, Atari. I have done reverse engineering, and I'm going to. I've always wanted to put together this presentation. Like I said, there's not a lot. We don't hear a lot about this. I don't think there's a lot of good material out there, and so I really had, over the last 2 or 3 years, had this passion to bring this presentation to you because I'm sure there's people out there that have to do this, and so how do you do it? So I want to just introduce you and inform you to the various tools there are in SolidWorks to do reverse engineering. So this, I had a gentleman earlier ask me, is this about taking AEC space, like building plant, and reverse engineering that? And it's not. It's based on product design reverse engineering or machine design engineering, reverse engineering, although there are principles that would apply to AEC. So I just want to go through a few slides to talk about what it is, what are the expectations. Half this presentation is going to be PowerPoint in the first half, and then the second half, I'm going to try to do live demo of some reverse engineering workflows. So I think we can do it. I did time it, and we'll just try to get through it. And if I move too fast, don't worry, because all this will be posted in a few weeks, and there'll be a presentation and the files that you can practice with. So if you feel like you missed something, you'll get a chance in a few weeks when the proceedings get posted on the website. So I want to explain the best practices and what to do and what not to do. And then really the heart of it is explaining 3 different workflows that we have in our product called Scan to 3D. Scan to 3D is a premium add-in, and you can go and add it in. And with it, you can do a number of things that you couldn't do with the base package of SolidWorks. You can do automatic surface creation of point cloud and mesh. You can also do what's called guided surface creation for product design, where you want to extract surfaces from the point cloud or mesh. And then, third of all, you can actually just use the mesh and draw directly on top of it with 2 and 3D sketches. Very, very useful. And I would say probably the most versatile workflow of Scan to 3D. I'll talk a little bit about preparing objects if you're interested. I won't spend a lot of time on that. Some practical examples and then a live demo. So as I explained before, we have this add-in for premium called Scan to 3D. And what Scan to 3D does is it allows you to take physical objects, or it provides you a tool to take physical objects and make them virtual. Now, you can combine it with many scanners that are on the market. You can see the Next Engine scanner here, Roland, laser scan, CMM, and other types of way of getting input of points or mesh. But our package actually, we try, in SolidWorks, you try to make things simple. And that's what we've tried to do with reverse engineering and the Scan to 3D add-in, as impossible as that sounds. We've tried to make it a really easy-to-use wizard interface where you can step through and align and clean up and mesh and make surfaces with this. And it provides a very useful, having that mesh provides a very useful reference for you to model to. There's things you just can't put calipers and mics on, right? You need, when you have more complex shapes or lots of different geometry that you need to model to, sometimes it's really very powerful just to bring in a scanned object and model against it. So that's kind of what we're going to talk about today a lot. And the other thing that's great about this tool is you don't have to go learn another tool. It's all integrated inside the SolidWorks environment. And I know a lot of you really appreciate SolidWorks because we do that. This tool is that. And it has support for many different formats. Many different mesh formats, many different point cloud formats. Okay, so what isn't it? And what is it and what is it? What isn't it? So it's a way of getting physical objects into SolidWorks as virtual objects. It's good for highly anatomical and organic shapes. And I'll show you that with the automatic surfacing. And it's basically, there's some things that are just really, really hard to model, like a femur or a tibia bone or some kind of anatomical shape. You can use this to get that into SolidWorks. Like if you're creating something for the hand and you need a hand reference in there, I'll show you how to do that. So it's also very good for getting quick concepts in. Say you're not designing something, but you're designing something for something like packaging for a product, and you don't want to rebuild that product. You just want the mesh to design a package around. Well, you don't have to make it solid. You can use the mesh, and you can actually section it and reference it to make your, maybe it's like blister pack or whatever. This is a really good workflow for doing that. Okay, so what isn't it? Well, it's not a complete reverse engineering package like Raindrop, Geomagic, or RapidForm. I'll be really upfront about that. Because it's very easy to use, it gives you a lot of the basic tools, but I have to be frank with you, even as a product manager for SolidWorks, it does not go to the level and depth of those products. And if you want to know more about that, we can talk afterwards about what the differences are, or you can go visit our partners out there and talk to them about what the differences are. This is really important. It's not an automatic one-button solution. It's not a way of automatically taking point cloud and turning it into a tooled surface. There's a lot between those two. And if you've done any of this before, you know what I'm talking about. This is not an easy thing. I mean, just to summarize that on that, it's not a one-button solution. It's not the easy button. You know, reverse engineering is really hard work, and that's why we probably haven't had many of these presentations in SolidWorks World, because it's a hard thing to do, and it's hard to explain, and it's hard to actually even do a live demo. So it just takes a lot of time. Okay, so reverse engineering, if you're reverse engineering something, we have to understand it's about interpretation, okay? This is really important. I call it the art of interpretation. You have to recognize this massive random cloud of points or mesh and somehow figure out how it was built using, especially if you're going to a parametric model, you have to identify, is that a planar face? Is that a radius? Is that a revolve face? Those kind of things to kind of reverse engineer the design intent of that part is going to really help you to bring it back into SolidWorks as a parametric model. The cloud point itself has no design intent. It's just basically a million mass of points that you have to somehow take, and we try to help you turn into a parametric model. Okay? So you cannot replicate a physical form to virtual, absolutely. There is tolerance and interpretation. This is really important because I talk about expectations. A lot, like you have engineering managers or clients that ask you to reverse engineer something, and you go off for a month and you do it, and you come back to them, and then they start saying, there's small differences between what you created, Mark, and what I see in this physical product. Well, that's just the nature of the game. There's going to be some tolerance difference because scanning, as good as it is not a vehicle for making an exact replica. And especially if it's going to be a parametric model, you have to take what was created maybe as a hand model and turn it into a parametric model. There's going to be differences there, and you have to interpret that. I'll talk a little bit more about that with expectations. And of course, you probably know this, that your end product is only as good as the information you get in. So if you get really crappy scans, point clouds in, you're only going to get limited information out. So garbage in, garbage out. Okay? But also, it doesn't mean that the more dense the mesh you get, the 600 megabyte point cloud file is really going to guarantee success for you, because maybe a lot of times too much information will bog you down. Okay? So it goes both ways. So setting expectations. Okay, I've learned this from personal experience because when I worked for IDEO, I had two occasions. One where I had a very high-profile industrial designer do some seat design. He was Italian, so I say no more. And he designed a very beautiful chair for Steelcase. I won't name who he is, but he had the expectation after I reversed engineered it in Pro E that I would be holding 0.5 10,000ths of a millimeter. Why wouldn't you? You know, you're reverse engineering it, right? Well, I had to explain to him that was just impossible, okay? And so what's really instructive for all of you is set the expectation up front about what it is your client or manager or customer is going to get. And just have them really understand those things, you know? It's, there's a lot of times that you don't even want some of the physical characteristics of the scan. Do you really want the parting line flash of the part? Do you want to have the sink marks? You know, do you want to have the pitting? I mean, these are things that, you know, it maybe sounds funny to all of you, but for people who don't know CAD, they just think, oh, those things are going to be in there. You're going to reverse engineer exact replica. Remember, it's not exact replica. And a lot of times there's imperfect symmetry, especially if it's made by hand. Do you want to correct that symmetry? I think you would, you know. Would you want to make something asymmetrical when it really wasn't intended to be that way? So keep in mind those things. These are all things, talk about them up front before you even start, before you even sign the contract or whatever you do, you know, because it'll come back to bite you. Believe me, they get really upset when they have an expectation that they're going to get a perfect replica from you, from their physical object into CAD, okay? Now, of course, I'm not talking about another segment of the industry like aerospace and military contracts where you have to really spend a lot of time to make an exact replica. And you create a machine part from that, and then you go back and you do inspection, and you do the round trip, and you have to keep doing that. That's a whole other field. I'm really talking about product design here. And I can talk about that too, but I don't have a lot of experience in that. I have visited a lot of customers that do that. So that's a whole nother game. Okay. So what's the process? So the first process, I'm just going to step through it, and hopefully, I know you want to see the live demo, and we're going to get to that, but I think the best way to convey the process and information to you and what it can and can't do is to just kind of step through these slides and have you understand it. And I'll try to keep an eye on my time, and hopefully I'll have enough time for that. So you can open up point cloud and scanned formats in SolidWorks. You have to first, if you have premium, you click on the add-in scan to 3D, and then another very important point is that you don't want to use the regular file types. You have to, when you open up a point cloud or scanned or mesh object, you have to drop down in the file type to the scan 3D types. Because when you do that, it reads it in a special way that you can use it. So just remember that. I'll show you that later. As you open it up, you have a couple things that you can do with the mesh preparation wizard. You can align it to be aligned with your default datums in origin. You can eliminate noise and simplify the mesh or cloud or point cloud. And then you can mesh it if it's a cloud point cloud. So this is at this point in the process, this is where you have to make a decision about what you're going to use to try to make surfaces and then solids. We have 3 different methods, and I'm going to keep reviewing these over and over. First and foremost is just the manual, what I call the manual method. Once you have a mesh in there aligned and cleaned up, you can just model directly on it. With Scan to 3D, you can actually draw a 3D sketch on your mesh, and it will snap to the vertices of the mesh. It's beautiful. If you've ever tried to draw a 3D spline in 3D, and you know how frustrating that is, it's a beautiful thing when you have a mesh, because the mesh holds it into 3D space as you draw over it. You can section it and draw a 2D spline and snap to the view section intersection in that mesh. I'll show that to you. That's manual building around the mesh. The second is automatic surfacing. That's good for things like hands and bones and things that are very organic and ornamental. You can actually make a single watertight surface solid from that mesh, and I'll show that to you too. And then guided surface extraction. This is the method for product design or machine design. When you have a machined part or a product type of part, you want to extract the analytical and algorithmic faces that make up that and reverse engineer it. And we can do that for you, where you can see in this handset, you can actually extract the planar, cylindrical, toroidal, ruled, and B-spline surfaces from that, and then knit them to trim, knit them, and make it solid and add the radiuses back. Okay. Oftentimes, it's the case with products like this that what you're really doing is trying to eliminate the radii and extract the important faces, make it solid, and then add the radii back. So it's a great way to take mesh or point cloud and make it parametric, because I'll show you that once it creates all those extracted surfaces, you can actually edit them in your tree and do even further refinement. Okay, so what are the advantages of these three and disadvantages of them? How do I choose? As I said before, highly organic shapes are good for automatic surfacing, where automatic surface solid creation, where there really isn't any kind of topology that defines fillets and cuts and things of that nature, but it's really organic shape that has no kind of product design parametric nature as we know it. And that's things like human parts, bones, very ornamental things that you really care less how it is. You just want it to be solid or a surface. Guided surface extraction is what I just talked about, where you have product design that you need to reverse engineer it all the way to the parametric level. You want to take that point cloud or mesh and you want to turn it into surfaces that then you can edit in SolidWorks. You can actually change them in a parametric history-based way. And that's where we're going to take those mesh, decompose them into identifiable surface types like cylinder, plane, toroid, and then build our model backwards parametrically from there. And then, of course, the manual method I just explained, where you just have a mesh and you just start drawing over it, and it's a very, very useful reference for creating your 3D shape in 3D with that mesh right there to reference to. Okay, so here's an example of automatic surfacing. I have this point cloud of part of this hip bone, and I brought it into Scan to 3D, and I click on the automatic creation choice, and when I do that, it prepares a network patch of surfaces. Okay, so it'll generate those patches, and you'll get something that looks like this, where you'll see you can see the random patches that identify the overall shape, the very complex shape. This is what you'll get. Now, you can adjust that slider to have more detail or less detail, and I'll show this to you. But oftentimes, I'd say sometimes, I found more often, that there are errors in what it can actually build a surface patch on. So we give you tools to actually mitigate that situation. So if you look here, we have an arrow pointing towards an aired surface. And what I'm going to do is use another part of this wizard to go and draw in more topology, a line, to try to rectify that situation. So if you click on Edit Feature Lines, you're able to add, subtract, to simplify edges. And that's what I'm doing here. So I'm drawing that line from between those two arrows. I'm drawing new topology in the surface patch. And when I do that, and I update the preview, I get the patch is solved, it's healed. But see the difference on the left from the right? I've added more patches, and that's the way it can solve that area of that bone. Okay? So that's how you use this part of Scan to 3D, this automatic surfacing, to have you figure out how to do these very organic shapes and make it a solid. That's the finished bone. So that's a solid shape. I could punch a hole right through that. I could start building, like prosthetic parts around it and things like that. And that's what that's really good for. Okay? Okay, let's talk about that second step, where we have product design or machine design. So I have this pump housing, and what I've done, I did this a few weeks ago on my next engine scanner. I scanned in this pump housing, and what you're seeing here is it opened up into SolidWorks as a mesh. It might look like a real solid part, but it's not. That's a mesh. That's what's cool about Next Engine, if you know about it, is when you open up the mesh, it brings the bitmap with it. So what you're seeing there is the actual photo bitmapped onto the mesh. And so I brought it into SolidWorks. I'm going to use guided surface extraction to reverse engineer this part. Okay, but before I do that, I'm going to start breaking it down so I can kind of deal with it in a more intuitive and easy way. The first thing I've noticed is that most of that part is symmetrical. Okay, so I don't need to reverse engineer both halves. I can just reverse engineer one half. So what I do is go into my surface mesh wizard and I cut it in half. I remove half that mesh, but before I do that, I copy 2 more instances of that mesh. The reason I do that is then I have meshes that identify different areas that I want to work on, but also those non-symmetrical areas. So you can see that that mounting tab on the left side is the only non-symmetrical part of this part. So I've copied over that portion of the mesh, and I'm going to deal with that on its own, but most of it's symmetrical. So when I get it to the point where it's solid, I can just mirror it, and then I can just add in that other part. So know that with Scan to 3D, you don't have to deal with the whole mesh at one time. You can divide it up into areas and work on those areas individually, because you can get overwhelmed when you think you have to solve for the whole mesh. And that's really important, because I get overwhelmed when I see all this information. I want to break it down into its digestible chunks, and that's what I've done here. Okay, so once you get the mesh aligned and you cleaned up and divided and put into a form that then you want to start reverse engineering surfaces off it, you go into what's called guided extraction. So when you go into guided extraction, what you're doing is you're having, first off, Scan to 3D decompose the overall mesh into its understandable parts that are going to eventually represent these analytical and algorithmic surfaces, like a cylinder, like a plane, like a toroid or a ruled surface. And that's what's happening here. So I'm in this part of the wizard where it figures out for me what parts need to be what. Okay? Now, it doesn't always get it right, and that's why once you hit that apply button there, you have a second part of this wizard that allows you to go and have Scan to 3D better understand what areas need to be those particular surface types. And that's what's happening here. You can see that when I go down into the manual painting, it's basically what you do is you grab a color and you start painting in the mesh in areas that you want to represent that surface type. Okay? So it's like a helper to Scan to 3D to help it understand what areas are planar, cylinder, B-rep, or whatever. Okay? And I'll try to show that too. So here's after I've done automatic and manual painting. I've cleaned it up. And this is how I see this part. Remember early in my discussion I said you have to be the interpreter. You have to figure out how this thing was made. This is how I think it was made, this pump housing, even though it's probably carved out of wood. Basically, that blue face, number 3, is a planar face. 2 is a cylindrical face. The little yellow triangles are planar faces. The blue cyan is a revolve. Okay? This is how I see it parametrically. So what I'm doing is I'm interpreting it from just random cloud point to what I interpret as a parametric model to help Scan to 3D extract these surfaces. So once I've gotten it to a place where it's pretty cleaned up, I go on to the next phase, and that's what you're seeing here. I'm going to extract surfaces automatically from these decomposed mesh colors. And so the way that happens is you click on those particular decomposed meshes, and you can assign, you can have it automatically do it, and sometimes that works, but sometimes it doesn't. But more importantly, you can actually go and identify what you think those decomposed meshes parts are. So in this case, I know that side face is planar. I'm going to click on it and assign a planar face. Okay, and it's just a process of doing that. Once I've got that, I click on it, I hide that. It hides the surface, the planar surface and the mesh, and I keep moving on to my other areas till eventually I have identified all the areas that I believe are the surface types. So once you've done that, you've created the recognizable surface types. Anything that's not identified is not created into an extracted surface. And that's where you can see these red areas. These are going to be fillets in my final model. So I don't care about those areas. I'm going to apply fillets in the final parametric SolidWorks model to represent those. But what I do care about are these larger areas, like the blue planar face, the green cylindrical face, the revolve. So what I mentioned, I extracted the planar face, I hid it. Now I can move on to that cylindrical face. I can identify it as a cylindrical face. I can make the surface, I can hide it, and I keep doing that until eventually, all my meshes are gone except for the red, what I call subsalient mesh decompositions. The B-spline face is particularly interesting because you can identify that, and it's basically making a boundary surface for you. What's even more interesting is that you can actually adjust the tolerance to get a tighter fit or looser fit depending on how much detail or imperfection you want in that face. And that's where interpretation comes in again, because if I make my internal UV lines like 16 by 16, it's going to fit very nicely, but it's going to start picking up all the imperfection also. So you have to interpret and decide how much tolerance you want there. So once I've done that, also what's really cool about this tool is that you can actually dynamically position where you want the curves in both first and second direction. So if there's one area of your mesh that's more detailed, you can move all the curves to that area and move less of the curves to the larger area that doesn't have as much detail. Okay, makes sense? So here I have half that model with my extracted surfaces, and at this point I take it and I kind of fast forward quite a bit here, but at this point what I'm going to do is I'm going to trim them, maybe use the intersect feature that you're starting to come to know in 2013. I'll try to show that, where you can take all those surfaces, trim them back to one another, make a solid model, mirror to my other side, do those other details as a separate guided surface extraction exercise, and I've got my model. This is the model that I created last week, and you can see the features in your feature tree that are mapping the guided surface extractions that were made through Scan to 3D. Okay? Okay. So, we've talked about automatic surfacing, guided surface extraction. The third workflow, and probably my favorite, because this is where you have total control. And that is where you actually just use the mesh. You don't go and try to make it a surface or solid, but you model against it. The advantages of that are that when you create 2D sketches, lines, arcs, splines, on a mesh or on a cross-section of a mesh, it actually snaps to the vertices of the mesh. So you can get some very accurate reproduction of a profile. You can also, with Scan to 3D only, you can actually section the mesh. So you can take your section view tool, in the heads-up toolbar, and you can section through the mesh. And then with it divided, then you get a very nice representation of the cross-section of the mesh. And you can actually sketch against that. And the best thing about it is that if you know SolidWorks and how to model in SolidWorks, you really don't need to know much about Scan to 3D. It's basically you use it to bring in the mesh and clean it up and position it, but from that point on, you're using all native SolidWorks tools, okay? And I talked about snapping to the vertices. That's very important and very valuable. But not only for sketching, but if you wanted to create a reference plane, like on the planar face of that pump housing, I can just pick 3 points of the mesh of that pump housing and I can go to my reference plane by 3 points, and it'll place a plane on those 3 points. So I have a very accurate reference for my planes right off the bat. And also we have some other tools in there too, like Curve Wizard. So if I have a mesh, I can actually use the Curve Wizard tool to make an automatic multi-curve section of that mesh. And then I can go use those curves to model like a boundary surface over that mesh. Okay. So just as I've done with the last two, I'm just going to show a little bit on this. So here I have a joystick, and it's a very complex shape. I forgot to bring it. It's actually in my hotel room. But it's a Logitech Wingman Extreme joystick that I did a couple years ago at IDEO, where I had to design it in Pro Engineer. And what we're going to do, you remember the file type I talked about? This is your open file, your open dialog, open file dialog. And you notice you have to go down to the bottom, and they have two different file types called mesh files and point cloud files. It's very important that you use those to open up your like STL or your OBJ. If you use the regular STL, it's not going to work. You have to use the actual one called mesh files and then the .stl file extension to open up a STL file and use it as a mesh in Scan to 3D. So you do that, and once you get that, then you can go directly to the Mesh Preparation Wizard. And with the Mesh Preparation Wizard, you can automatically create a mesh from that point cloud. You can do a lot of other things too, like clean up holes in the mesh. You can align it. I'll get a little bit more into that and show that, hopefully. And then once you have your meshed cloud point, as you can see here, this joystick, now it becomes really understandable, right? We really want to work with a mesh, not a cloud point, because cloud points are hard to understand. So now that I have this mesh, I can start modeling directly against it. And again, you remember I talked about the view section? You can create, so just follow this. So now I want to start to create some extruded planes for this top button interface of my thumb. So I put a plane through there. I use view section, I section the mesh, and then I start drawing a 2D sketch. And you see the little orange point there? That's snapping to the mesh itself as I draw. So I'm going to draw these lines that are going to create this planar surface, and now I have it perfectly aligned to the mesh. Now, you might be asking, well, Mark, are the points parametrically constrained? No, they're not. Okay? And they're not on purpose, because remember, we're not going to change that mesh, probably, because remember, we're reverse engineering something. We're not going to go through a concurrent engineering change. So when you snap to the mesh, it's a one-time snap. And that actually is to your benefit, because then if you want to move it, you can do it freely. You can actually reorder sketches over the mesh and in front of the mesh. It doesn't matter, because there's no parametric constraint there. So in this case, I'm going to extrude a surface, and now I have that extruded surface. But I've noticed that I'm asking myself, Mark, it doesn't look like that is really planar to that top part of the controller that I know is a planar face. So what happened probably is that I didn't align it very well when I brought it in. So I'm going to rectify that problem. The way I'm going to do that is I'm going to go find parts of the model that I know are very accurate, and I'll show you where those are. And I'm going to realign that model by creating a new coordinate system where I think it should be with a newly aligned planes. And the reason I'm going to do that is because then I'm going to round trip it. I'm going to take the mesh outside, I'm going to export it and re-import it on that new coordinate system. So now I have a perfectly aligned mesh when I open it up again. Okay, so I'm using the trick of building a new coordinate system with new references, new references and new coordinate system based off those new references, round-tripping it and bringing it back. So that's what I'm doing here, and I think I stepped through that here. So I know this plane is planar, okay? So I create a 3-point reference plane to create a planar, a reference plane. And with that, I also take this cylindrical face on the bottom of the controller. I know it's cylinder. It's a very nice reference. I have a good mesh of it. And I automatically extract a cylinder surface from it. Remember the guided extraction? I can do that. So I take that in combination with that other plane, okay, and I build a new coordinate system, basically. You know, I build a new front plane, a new top plane, a new right plane, and a new origin, which is my new coordinate system. So when I do that, I now have everything I need to export it out on the new coordinate system, and you know you can do that with Parasolid and other formats. When you save it as like an OBJ, I can say, I want to save this, but I want you to reference the new user coordinate system. So when I do that, I export it, and then I round trip it back in, and guess what? Now I've got a much better, a much closerly aligned plane with that top. So there's lots of tricks like this that you can use a combination of all three of these workflows to really help you out. Okay? I talked about the curve wizard. This is an example of that. So we have a wizard in there where you can actually take and automatically create sections of curves through your mesh. And that's what I'm doing here because I'm going to create that side of that hand controller with a boundary surface. I'm going to do it through a multiple guide curve, or I'm sorry, multiple boundary surface curves. So you can see here when you go into the wizard, what you have to do is you have to first identify the direction that you want to build the curves. Okay? The second thing that you do is you identify the start point. And that's really cool and really helpful because you can say, I want the first curve to start at this point on the mesh, and then it's just a matter of the spacing and number of sections for the curve. Pretty easy. Okay? But if that weren't enough, you can now go in and edit those curves while you're in this tool to loosen them up or tighten them up in their tolerance. And we put a curvature plot on them so that you can see. And here you can see the difference between me tightening the tolerance by sliding the slider to the left versus loosening the tolerance by sliding it to the right. Okay? There's also some other tools in there for adding new points, for deleting points, for actually breaking and trimming curves. So you can do a lot with that. Okay? So there I have those curves, right? I've chosen not to use any of those other curve tools like trimming and whatnot. I'm going to go into them individually and work on them because I'm comfortable working in Sketcher. So that's what I'm going to do. But before I do that, let's go back. So you see that last slide? So we could create a pretty accurate surface just with those if we clean those curves up. But what I want to do is also create cross curves. So if you've done any surfacing, you know that boundary surfaces are most powerful when you have first and second direction curves. And that's what I'm going to do is I'm going to roll back. So it's created that one 3D sketch with all those curves in it. I'm going to roll back before it. I'm going to do a view section through my mesh. And now I'm going to draw on that intersection of the view section a 2D spline, snapping to that intersection of the mesh, and create these second rail curves, or these second direction curves. So I've done that, and I made them, I purposely not put a lot of points in there. I've tweaked the vectors and magnitudes to make and turned on my curvature to make a very nice smooth curve, okay? So with those, I have that job completed. I roll forward, and now I go and I tie together those curve wizard curves with those second direction curves, okay, because they have to be tied together, and that's what I'm doing here. You see the image on the very right, you can see now I've taken each of these curves and I've cleaned them up. And I've also connected them either with a pierce or a 3D constraint to those rails that I created just before them by rolling back. So with those, now I've got everything I need to be able to create my 3D boundary surface. And just a little point here is that I find the 3D sketch triad extremely useful. These are 3D curves, and using the 3D sketch triad, you can very accurately reposition interim points and endpoints of splines. And you might not know it, but you have a property manager there too where you can numerically control very small distances. Sometimes that's the case, right? You just have to move that interim spline point a very small distance. Try using the property manager that comes with the 3D triad to do that by just entering numbers there, very small numbers. So it's a very great help for tweaking and making curves smooth. So now that I have everything, I've actually created a boundary surface. You can see I have a pretty good fit, right? But, you know, I'm an industrial designer and I'm a perfectionist. I'm not happy yet. So it's not good enough for me. So what am I going to do? I'm going to go back to PowerPoint. I'm going to actually roll back again, and I'm going to add a third second direction curve. This time, I'm going to go on the side of the mesh and create a curve that is in between that first and end curve going the opposite direction. And here, I'm showing you where I'm actually drawing a 3D spline directly on the mesh. And I'm not losing anything in 3D space because I'm snapping to the mesh. It's like spline on surface. I can actually draw right on the mesh surface. And it's really, really fun to do because we know how much of a pain it is to draw a 3D spline, a 3D sketch spline in a 3D space in a isometric view. So that's a really cool way to do it. But if you don't want to do it that way, you can also, section that area and draw another 2D spline that is a perfect, almost perfect representation of the cross-section of that area of the mesh. Okay? I have to be careful because remember, I'm the one that's saying it's never perfect, right? You always have to do a little bit of interpretation, especially if you want that spline to be very smooth. You can see I turned the comb on here and gave it a very high density because I want to have a very smooth guide curve, a very smooth spline as part of my boundary surface. So I'm using the coolness of snapping to the mesh, but in the same way, I'm also adjusting it to be a very smooth curve. So you use the best of both. So now, because in SolidWorks, you don't delete anything, you don't trash anything, you modify everything. So what I've done is I've rolled back, I've created a new curve, and now I'm going to edit the boundary surface and include that curve. So what I'm doing is I'm reiteratively making my boundary surface more and more accurate by adding new curves to it. And that's what I've done here. I add this new curve, and now you can see if I compare the mesh between the two models, I see more of that mesh coming through the boundary surface, which means that I'm getting closer and closer to the mesh. Okay, and that's my goal. Okay? So just to summarize the three different workflows, we talked about automatic surfacing, good for organic shapes where, topology and parametric topology isn't really important. It's just that I need a solid organic shape to do something around. There's the guided surface extraction, where it is important that this is a product or a machined product where I need to extract the analytical faces that will become parametric features. And then the third one where I want total control. I want to basically just use the mesh to model against and build up my own surfacing with the familiar tools that I know of in SolidWorks. That's the three step. Those are the three workflows. Okay, and what I hope you bring away from that is that one size does not fit all. You can use all three. You notice I used the guided surface extraction just to get that bottom reference from the mesh so I could export it and re-import it. So use them all three together, and don't just work on one mesh. Copy your mesh and divide it up into different parts that are going to suit what areas are good for what. There might be part of your model that is very organic and you want to just do that automatic surfacing, but there's another part of it that's very analytical. It's very machine design type, and you want to use guided extraction for that. You can combine the two. You can combine all three, and usually you do because there's no one-button solution. There's no real automatic surfacing. I don't care if you're using Geomagic either or Rapid Form. It's the same methodologies for them. Okay. So let's talk a little bit. Let me see where my time is. So we're at 5:14. I've got about a little over 45 minutes left. That's okay. So just a little bit on preparing models. I used the Next Engine scanner on this particular example. And with laser scanning, which is the Next Engine scanner, oftentimes the laser finds it very hard to read the surfaces, especially if they're shiny or they're gloss, and you want to do something to prepare them. And some of the tricks I have, if you can paint it flat white or an off-white, is the best. Laser scanners love flat off-white surfaces. Okay, so if you can paint it, do it. Okay, and make it a flat white. If you can't afford to do that, and it's going to destroy the part, then you do have other alternatives. There's what we know, what some of you, I know a lot of you machinists know this product, die-chem. So it's a marking tool, so for marking metal. And you can use die-chem to spray on your part, and they also have a decleaner, and you can use this without destroying your part if it's very sensitive, okay? What I did on my part, because I didn't have any die-chem around, I didn't want to go buy it, is I use a combination of baby powder and hairspray. So I first hairspray on to that pump housing a coat of hairspray, and that becomes a bonding agent for the baby powder. So the next step is once I hair dryer it a little bit, then I coat it with baby powder, and now I have a fine white kind of dust all over the metal cast part that becomes a very good surface for scanning. And you can just see some of the pictures here. So here I am spraying the hairspray, and you want to do it in an area that you're not going to get it all over everything. And then I'm dumping on some baby powder. But I found that also what's really good is to put it in a bag, a Ziploc bag, and put baby powder in there and then shake it around. Now it gets a more even coating on that. And once I get it out, I take a paintbrush and I just kind of get the excess off. And you have a nice, it's like coating chicken if you do fried chicken, right? It's not rocket science. It's just that's how we do chicken. Okay. And then the next step, of course, for laser scanning, and in particular the next engine scan, is the way it basically works is that it has a rotating table, and it takes several scans 360 degrees around the object. But to put all that together in a way that the user gets involved a bit, aligning those different scans into one mesh and then fusing it into a single mesh. And that's what I'm doing here. I'm taking a Sharpie marker and I'm putting down what's called correspondence points. And those correspondence points will be very helpful for me when I start aligning this scan pass with this scan pass. I say, connect the dots. This dot goes to this dot goes to this dot, and doing that, it understands in 3D space, because you do have a three-dimensional scan in there, it automatically aligns them together. And then it even does more to get down to a very high tolerance, like in the 1 to 2,000 range. My final scans for this one, I got within like 0.002 of an inch, which is pretty good for that scanner. It's a first generation scanner too. They can get much better now. That's my setup. So you can see it on the platform, and there it is being laser scanned. And that's essentially it. Great product because it's very office friendly. Here's some practical examples. You saw the joystick, so this is kind of like the multi-step process. There's the mesh on the left, and then I'm building my curves, I make my surfaces, and I have the solid. That's the manual method. Here's a nice example I did back a couple years ago for SolidWorks World, where I created a ski mask. I scanned one of my SolidWorks colleagues' face and used it as a reference to build the ski mask. So she has a ski mask now that fits her perfectly, and only her. No, I kind of loosened it up to be more generic, but you get the idea. This is great stuff for building products around the human form. That's really what it's about. And of course, maybe some of you have seen this model that just came out that I finished. It took me about a year to in a sense, reverse engineer a Porsche Carrera GT. So this model really, I wasn't able to do it without actually scanning a die-cast metal model first and using it as kind of a loose reference for my finished surfaces and then the solid model of the Porsche Carrera. So it's got lots of uses to do stuff like this. In this case, I used it as a manual reference, and it became a very, very, very helpful because all I had was high-resolution photographs off the internet of the Porsche Carrera. There's only about 100 and maybe about 400 in America. I've only seen one in person, so I'd rather just go out and buy one, but I couldn't. That wasn't an option with my wife. Anyway, a couple tips. and I'm just going to review a little bit, and then hopefully we'll have like 30 minutes left to do some live demo. So know what workflow you're going to use. Now I've educated you on the different workflows and what they're good for. If you have a real organic part, automatic surfacing might be the right thing. If it's a machined part, it's going to be guided surface extraction. If you want total control and you're really not sure about those two, go right with manual mesh and just model right against the mesh. You also, I find it helpful, turn off perspective view. There's some weird things that go on with meshes and when you have perspective view on. So I just, especially dimensioning, dimensioning in 3D space doesn't really work well. It's been a long time problem with our scene graph. So I turn off perspective. And then remember, like I said before, don't feel like you have to go through every step of the wizard and complete your job in one pass. You can do parts of the wizard and just exit and just do those parts of the wizard. Save your file. And then go back. Like, oftentimes I'll just go immediately before I even line the point cloud, I'll just mesh it, exit the wizard, save the file, and then go right back in again and align it. So don't get, I know it's, you think of the wizard that you have to kind of step through every step of the wizard. You don't. You can do individual parts of the wizard. Okay? Yeah, and also remember that scan to 3D wizard for mesh alignment is not parametric. It means you can't do an undo. So you want to save versions of that. If you want to get back to where your original mesh was, I'd recommend you just save the mesh, imported, or keep that mesh around, because it's not parametric. You know what I mean by that, right? It's not history parametric. It's not a feature that gets populated into your feature manager. So again, I talked about when you're painting your meshes, think about your parametric model. Also, if you have very measurable parts of your model, like holes, and you've got calipers or a mic, use them. Don't rely on the mesh, rely on your calipers or your mic. Because, the mesh isn't perfect, but you could probably get a better read off of a bored hole by just miking it, okay? And then also, and this is really key, you're going to have to learn surface modeling, I'm afraid, if you do a lot of this, because there's a lot of surface modeling that has to occur between building up the mesh from a surface to a solid. So getting to know your surface modeling tools is going to be invaluable for you guys. I hate to say that because I know you want it just to be a one-button solution, but it's not. Okay? And you can contact me with any questions. So I think I can get to a live visit here, or what am I saying? A live demo. What I meant to say is that we also have this product definition, and I'll explain this at the end, but I won't spend time on that right now. Let's go right to doing something in SolidWorks. So I'm going to open up this mesh that I have. So here's the pull-down type that I talked about, right? Here's point cloud files, and here's mesh files. I have a point cloud file here of this mouse design, and I'm going to go ahead and open it up into SolidWorks. And this is what you get. Now, this isn't a really dense mesh, just because we don't have time, to wait for it to mesh. So I picked something that was kind of average mesh size. This is what your point cloud is going to look like inside SolidWorks, okay? So once I have that, I can right-click on my point cloud in my feature manager, and it can go right to Mesh Preparation Wizard. Okay, so when I do that, I have a number of steps in my wizard. The first one you probably might want to do is to align the mesh. So in that second step of the wizard, I have these tools for actually aligning the mesh. And I got out of this because we do have a little limitation on this product, and that is I can't turn on and off my planes while I'm in the wizard. And I'm trying to get that fixed. So just remember that. I'd also recommend going with like a white background. So here you can pull down to plain white, I believe, if I can find it. There. Okay. So let's go back into the wizard. I'm going to step over to the orientation part of the wizard and click on numerical input. And here, I really like to use my different views. So like in my front view here, I I know this wants to be my front view, so now I'm going to start orientating the point cloud in a way that makes sense to me. Let's start with the top, though, first. So I'm going to go down to the top. And then I can start to use these scroll wheels, keeping my eye on the global origin. I know in this case I want to rotate the mouse this way, or the mesh, so I'm going to rotate around my Z. So I'm just going to turn my Z like this. And you know what? I got to make sure that I'm not looking at the top instead of the bottom. So, yep, I made a mistake there. So I'm going to go the other way. So I'm going to rotate it around until it looks right. And also notice that if you're on scroll wheels in SolidWorks in general, if you hold down the Alt key, it quarters the value of increment of acceleration. So I'm holding down I'm now holding down my Alt key, and look at my scroll wheels moving much slower. Okay? Let's go to my right view. And now I'm going to work off of my x-axis to rotate. Okay? Then I'll go to my front view, and looking at keeping an eye on my global triad here, I know I need to rotate on my z-axis. So again, I'm just going to hold down my Alt key, and now I'm getting some good alignment, and now I can start kind of repositioning it, orienting it in 3D space. So that's what I'm using with these Noom boxes. And eventually I get, what I want as far as my orientation. So again, going to my top view, off of my y-axis, I can rotate, hold down my Alt key to get finer increments. Okay, I want to move on my x-axis over. And I'm basically, you get the idea, you're just centering it. You also have some other options where you can actually pick mesh points, and it'll reposition to that mesh point. But here I find this most valuable. So at that point, I've got it, the way I wanted it aligned in 3D space, okay? So I'm going to go forward, and now I can do some other things. I can remove noise. Oftentimes in point cloud, you have noise. You have points that are way out in space. And you can use this tool just to eliminate those and clean it up. It's basically cleanup. You can also eliminate parts of the mesh with this tool. So I could eliminate, if this is a symmetrical part, I could actually eliminate half the mesh by just taking these tools and just cutting through it and getting rid of part of that mesh. What I want to get to is just making the mesh itself. Oh, you can also simplify the mesh. So if you have like a 10 million point mesh and you know it's going to bring your SolidWorks to its knees, you might want to use this. Okay? So here I'm going to construct my mesh. And you can see down there at the bottom I have 4 choices on what algorithm it uses to create that mesh. You have the default, which is random, but you also have curvature and uniform. I don't have time to explain these. I like uniform the most, if you just want to make that note. But here I have my mesh. So now I really understand this a lot better, right? There's my mesh. If I turn on my edge view, you can actually see what that looks like. There's the mesh. And I have some holes here. Okay? So I can go to my next step and actually automatically fill those holes. If I actually wanted that hole, all you do is you click on it and you eliminate it from the wizard to eliminate and fill in. But I do want that hole, so I'm going to click on it. And then as I complete my mesh preparation wizard, I now have, a nice mesh that I can model around. And at this point, I have to make that decision. What am I going to do with it? Okay? So what if I wanted to do automatic extraction? Maybe I didn't come to this presentation, and I'm just, automatic sounds good to me. I'm just going to make an automatic surface, okay? And thankfully, I got them to change this. We didn't make it the default, okay? I think guided extraction is more the default. But if you click on automatic, let's give that a try and see what happens. Okay, so now we're going to generate those surface patches. I think you'll get a feel why this tool doesn't work for product design. Okay, there it is. That's a solid. Okay, but let's go ahead and complete it. And what do we really get? Okay, that ain't so nice. You see what I mean? So the automatic surfacing tool doesn't really work for these types of objects. It's really good for really highly detailed stuff, but it does make it a solid model. I mean, if I want to punch a hole through this just to prove to you that this is solid and you don't believe me, let's go ahead and just punch a hole through it. Okay, and I'll go both directions. And there you got it. That's solid. Okay, but that doesn't work because, it picks up all the imperfections, and the automatic surfacing has a certain amount of tolerance that's not good for product design. So I hope you can see that that's not really the best thing to do. And also notice that how the patches are laid in. There's really no rhyme or reason. I mean, that did a pretty good job, actually, but that's not going to be something I can edit, right? When I want to make that mouse, a little narrower, or put even a fillet right here, I can't do it because it's already included that as part of that surface patch that became solid. Okay. What I would rather do, so let's move on to the other ones. Let's open up, just for the sake of time, I actually have a mesh here that I've aligned, and we're just going to bring that in again. So we're back to that first step after the mesh preparation wizard, where now I'm going to take this and let's do some guided surface extraction, okay? So that's kind of the better method for this. I'm keeping an eye on my time. So it's 5:30, I have about 29 minutes. Let's see what we can do. Okay, so we have our mesh. We're going to go right to guided surface extraction. We're going to go to the surface wizard. The mesh is pre-selected. Guided surface extraction. Oh, we can split. We put this tool in here. If you wanted to, if it's a symmetrical part, you can just split it right here and just work on half of it. But I'm not going to do that because this is actually asymmetrical, as you can see. And then we're going to go right to it figuring out how to decompose this mesh into its various parts. So that's what it's doing right now. You see the progress bar down at the bottom? There we go. So that's its default setting for decomposing the mesh into its various surface types. They're not surfaces, they're just decomposed meshes that are going to represent their surface types. Now at this point, this is where I get involved. I'm going to say, you know what, that's pretty good, but I'm going to have to do some work painting in some areas. Oh, and by the way, if you slide the sensitivity, see what happens? So if you can make it more sensitive, it's going to try to divide it up even more. As I slide my slider bar, if I go all the way to the right, I get one mesh. Okay, so I pretty much like where it put me on its default, and I'm going to go in and start to apply some of my intuitive knowledge to have it better understand how to decompose the mesh. So I'm going to say apply, and now I'm going to go in and start painting in areas that I think should be parts of those decomposed surfaces or extracted surfaces. So I'm going to pick, it's basically, you have an eyedropper tool, you pick the color you want. Here, let me hide these planes real quickly so you can see. And I'm going to go in and I'm going to start painting in areas. So, in fact, what I'm going to do is I want this to go all the way around the outer boundary up to this point of the entire side of the mouse. I want it to be like a B-spline or a ruled surface all the way around. So I picked this color, and I'm going to start painting in this area. And when I do that, and you do it carefully and you can close that paint area, it'll automatically fill. Okay? But while I have that color selected, I also have a paint bucket tool. And with my paint bucket tool, I'm just going to fill this area the same color and include it. Okay? I'm going to do a little bit more cleanup. I want a better edge down here, so I'm just going to use my paintbrush tool again to just kind of clean up this area. And you know what? If you have a Cintiq or a Wacom tablet, this becomes really much easier. It's pretty hard to drive and paint with a mouse. So if you do a lot of this, you might want to consider a Cintiq right-on tablet monitor or a tablet to do this kind of work. I'm going to go ahead and pick this subsalient mesh. That's the one that's not going to be included. And I'm just going to paint in these areas a little bit more. Go back and pick this color, paint in these areas, just clean it up. You don't have to do a perfect job, it's not that critical. And I really don't have a lot of time to do this, so I'm just going to go in and pick a few more areas. So I know these little divot areas here, I want these to be individual surfaces, so I'm going to pick a new color. So I'm going to make this like a bright green, and I'm going to paintbrush in these areas here. Okay, that's going to be my little divot on the side. And this is really important, guys, when you do this. Be careful not to extend the boundary of paint into areas that you want the guided surface to try to interpret. Like right here, that's part of that radius. I'm going to apply this as a radius later on. So I'm not going to let that be part of the solution, per se. I'm going to actually bring it really inboard. So I get just that kind of toroidal surface in there and do that. Okay? And I can do the same thing with these guys. I'm just going to paint in a pink here for these divots. Okay? You can use the paint bucket or you can just keep painting. Okay, and go pick a new color. Don't spend too much time deciding on colors. Industrial designer in me. Yeah, you get the idea. Here I've kind of gone over a bit, so I'm going to sample that and then paint that out. It's kind of an additive, subtractive process. And then pick one final color and do this third divot area. Okay, paint that in a little. Let's paint this out a bit. Okay, and I think I've got enough to get something useful. Okay, so there you go. Kind of makes sense? Oh, there's my planar surface for the bottom. So now with that, I'm just going to go to the next step in the wizard. And now we're going to extract those surfaces from those decomposed mesh parts. So I'll start with the bottom surface, the simplest. Make it planar. So there's my planar surface. I'm going to hide it and then keep moving on. So it's about, making those surfaces, hiding them temporarily and just keep moving down until you have no mesh left. Let's move to the top. So let's pick this. And I know for a fact this is pretty swoopy, so it's going to be a B-spline surface. So it puts a B-spline over it. Now, remember that part that I showed you in PowerPoint? This is where I can go in, and if I look down into the wizard, I can adjust my tolerance. Right now I have a max deviation of about 18 thousandths of an inch, and I have an average deviation of 2 thousandths of an inch. If I don't like that, I can change the amount of cross sections in my U and V. I don't think I need that many, so I'm going to step it down and see what I get. So I've got 7 second direction curves and 6 first direction curves. And then I do a rebuild of the surface and watch, let's see if I get better or worse deviation. I get worse. Okay, it's up to 28 thousandths of an inch in that area. So I'm going to go ahead and add one back, but maybe what I'll do is I can edit the curves by moving them into areas that I think they should be. So I'm going to move these curves around a bit to kind of better represent where I think they need to be to get a better fit on the overall mesh. So that's what I'm doing here. And then once I do that, I can hit Rebuild Surface, and it refits the surface, and I get my deviation analysis. It's still not as good as what my first solution was, but I did that just to be instructive about what you can do when you have it. So it was a pretty good fit. I think it's good enough for right now. We're going to move on. So I can take, and I'm done with that surface. So, oh, that's right. I have to turn off my edit curves. Okay. Now I'm going to hide that. I'm going to move over to this surface, and I'm going to do an extruded surface. Okay, so it's kind of fitted an extruded surface through there. I like that. Let's go ahead and hide that. And this one here, this is an odd one. I'm going to try extruded or toroidal. No, not toroidal. So when you try and fit surface through here and you don't like them, you just delete them and try again. So I'm going to try an extruded surface, and that's what it looks like. So that's what I'm going to use. Okay, so I'm going to hide that. And now all I have left are these other surfaces, and I think they're basically just B-spline surfaces. So I'm just going to do that. I'm going to take the mesh, the UV sections way down. And it remembers your last setting too. So when I do that, and I hide it, and I go on to the next one, like this one, it remembers that setting. So that's what I'm going to do. I'm going to take that one, hide it, and I'll just keep going. So that one, I don't have to hide them, by the way, at this point. Okay, there we go. So now we step forward in the wizard, and now what it's going to do is it's going to go and build all of those, and I'm done, basically with my surface extraction. Okay? So what's left now is just to make this thing solid and to knit all those surfaces back together, have a solid, and then apply our fillets. So I'm going to do some things here with surfaces. I'm going to extend these surfaces on this mesh a bit forward. Let's take this guy and extend it. Okay. And it looks like I've got most everything to actually go right into solid. Now, the tool that came into 013 called the intersect tool can be extremely useful for this. So I'm going to go to Features, Intersect. I'm going to pick my surfaces. Just have to make sure I pick all the right ones. Do I have 4 or I have 5? Let's see, 1, 2, 3, 4, I think, right? So if I do intersect, yeah, click OK, I have a solid model. Oh, you know what I forgot to do? Is actually down at the bottom you can consume surfaces. So there I have a solid model. So now it's a matter of just going in and then putting back the fillets. So here I know these are fillets, and I'm going to adjust them. I think they're 2-inch. And you can do more adjustment with Instant 3D to try to get a good match to your underlying mesh. And then it's just a matter of taking these particular, like for instance, if I take this and I know I need to extend that a little bit more, and do it to the extent that it actually comes past my solid, and then I'm going to, that's not quite enough. So let's go with, what I do, hide it? Too fast. Let's go up to like 0.4, see if that's good enough. You can't go too far because then the curvature actually starts to wrap around. But what is instructive, what you need to know is you look at here. This thing is actually a boundary surface, if I can find it. See if I can highlight it. Okay, this is still a B-spline, yeah. But that top one, for instance, right here, that's now a SolidWorks parametric feature. So I can go back in there and continue to fit it more nicely to my mesh. And that's really helpful. So the idea here is then, all I have left to do here is to create my fillets. This is a solid model now. I can hide my mesh. And that's basically what that's all about. Okay? Let me take a look at my time. So I have 15 minutes left. What can we do? Well, we can take, let's do this. Okay, let's say, for instance, now, we don't like either of those processes. Let's do the manual method. So let's open that up again, right here. And now we're going to do the manual method. So here, what I want to do is I want to just use the mesh and start building all my surfaces using sketches and boundary surfaces and fill surfaces. So I'm going to go ahead and take this plane, and I'm going to use my view section to section through it. Okay? And then on this plane, which is my view section, I'm going to create a sketch. And as I do that, now watch what happens. So as I create this sketch, you notice the little orange dot? I'm snapping to the mesh vertices that are at the intersection of that area. Now, I pulled it away there because there's actually a divot that dives down, and I won't be part of that, okay? But you can see how that works, right? Really nice. You know, if I turn on curvature now, I can see what my curvature's like. I have a little bobble there, so what I can do is actually eliminate that point and do a little adjustment on the vectors and magnitudes to get a little better curvature flow there. But that's the idea of creating directly against the mesh. Now, here's the thing I really like, is that in 3D sketch splines, drawing them in 3D space is a pain, right? Because you really don't know where you're drawing. But with a mesh, it's beautiful. Because if I go right to my 3D sketch tool spline, watch what happens. That's where you can really have the power of a mesh in your SolidWorks environment. Because now you can really accurately draw 3D sketch splines with that mesh. So it's really, I think you can, I don't think I need to go further on this. You can understand how, then you can take these curves, make surfaces to replicate a boundary surface that makes that top surface, and just do what guided surface extraction did. Okay, so that's kind of the manual method. So just back to the PowerPoint really quick. I did want to highlight this slide. I'm a manager of product definition for, along with a couple other managers, and all of us go out and visit customers one-on-one every year. We actually have a quota to go out and visit customers for a couple hours, and what we do is we sit down with you. We first understand your business, try to understand your business and your design process, and then we want to really have you really spend most of the time telling us what you think needs to be improved in SolidWorks, what issues you have, what enhancements you want, both at a very specific level, at a very high level, and we take those back, and we're the guys and gals that actually write the specs for new functionality in SolidWorks. So we'll take your suggestions, and we'll weigh them against other users' suggestions, and that's what those suggestions actually become development projects that eventually become new features in SolidWorks. Okay, so it's your most direct avenue. If you have something you're just burning to have in SolidWorks, the best thing to do is phone one of us up for a customer visit. I'll have some cards out here in front, and take one. If you want a customer visit, please contact me. Okay? We also have a second type of visit, which is called a consultant visit, and that's where we come out for a couple days, and we actually sit with you, kind of embed ourselves, and we actually model with you. And we have a more kind of intense, intimate situation there where we can be on site for a couple days to help you with your modeling and answer your questions. And that's really valuable for us because then we get a firsthand view of what your situation's like, and we learn a lot through those too. So anyway, we have a little bit of time for question and answer. And I'm going to put my cards up here on the podium. Please take one. I'd love to hear from you. So questions and questions? Yes? No, because a plane is really only defined by 3 points. Are you talking about for a reference plane? Or for a planar surface extraction? Yeah. You can pick any of those tools you want. How successful they're going to be is the question. So if you have what you think is a planar surface and you pick 3 or 4 points on it, I mean, you're really not picking points. You're just picking the decomposed part of that mesh. And if you identify that and you go to one of those tools like plane and you pick it and it looks like the right solution, bonus. If it doesn't, then you're screwed. You've got to go to the other ones, like maybe it's a toroidal or a ruled surface. So that's what remember I talked about interpretation. You get involved in the interpretation. You help SolidWorks understand what those individual surface, decomposed surface meshes are. You got to speak up a little. I understand, yeah. It's as much as memory you have available. I've brought in a 10 million point cloud for one customer. Mesh. Points are very hard to visualize, right? That's why I went immediately to mesh, because then the mesh gave me a three-dimensional representation of it, right? The mesh, the point cloud was very hard to read, right? You know, especially for architectural, if I were to laser scan this room, you know, you could kind of understand it, but what you'd want to do is just immediately start making reference planes or planar surfaces of these walls. You know, and get as fast to that as possible. Because that's what we understand visually, right? Yes? You know, I don't know what to tell you, how much memory you need per how much point cloud. I've opened a 10 million point cloud on a 8 gig system. Okay? But that's not the end of it, because when you mesh it, then that's an additional load on top of your memory. So just bringing in the point cloud if you can open the point cloud and you do a sigh of relief, that's not where it ends. It's when you actually make it a mesh. So if you can bring in a 10 million point cloud and then make it a mesh with 8 gigs, then that's great. You know, it's really when you get to the mesh. Because then there's graphics involved. Yes?
I came across a website where you're supposed to be able to take a bunch of digital pictures of an object from all around it.
Right.
Upload it to the site, and then they come back.
Right. Autodesk, right?
Something like that.
Yeah.
Did you have any experience with that, or does that work?
Yeah, that's a really cool thing that's been around for a while. You know, Google Maps, the whole New York downtown was done that way. You know, they took pictures of buildings and they mapped them onto primitive 3D models and actually figured out the basic dimensions of the model from the photometric data that they took. It works well for simple things, for simple planar faces. When you get into stuff like I was working on, no. No. Maybe someday. I'd love that. They got to keep working on that. Questions? Any other questions? Yes.
With your next engine, are you sticking with the core software it came with, or are you using the add-on software?
I'm using the core software, just the Scan Studio. The Scan Studio that comes with Next Engine does all the alignment and meshing and taking it to SolidWorks. Now, Next Engine for the last couple of years has bundled RapidWorks with it, and you're free to use that too. You know, that RapidWorks is basically a duplication of what I showed with Scan to 3D, okay, and maybe a little more.
Do you spend a lot of cleanup time in the Next Engine piece of software, or do you bring it all right in SolidWorks and do the cleanup in SolidWorks?
It depends what workflow, right? If you're just going to be using it as a mesh reference and you don't care about a little noise and garbage around in your 3D space, don't clean it up. They make a pretty good tool. I mean, they have our philosophy. They wanted to make reverse engineering very simple, and the tools that they have, I think, work really well. They're very simple to use. Yes?
I opened the STL files in SolidWorks, and it's like a dumb, you can't touch it or see it.
Yeah.
That menu you showed us,
Yeah.
you have to pull the add-in.
Yeah. Right. Yeah, great question. His question was, he's opened up STL files in SolidWorks, and when he gets them, they're just a graphic body. You can't do anything with them. You can't even put a view section through them. The only way you can get that with what I showed is if you have the Scan to 3D add-in, and you also drop down to the file type that says either point cloud or mesh data. Once you open up the STL file using one of those file types, then you can do what I do. I can snap to the mesh, I can section it, I can do all those nice things. Okay, does that answer your question? Yeah. Oh, and you can make an STL model solid with just your core SolidWorks, but you're not going to like what you get. Because all it's going to do is it's going to take all the faceted triangles and make planar faces and then knit them all together and make a solid model. And you'll get the most expensive or the most odd-looking diamond-shaped object you'd ever want. Kind of get the picture. Other questions? Okay, well, thank you very much.